Okay. On the Chapter 6 review, the very first problem asks you to rewrite without rational expressions and simplify. So they're asking us to rewrite without rational expressions, which means they just don't want the square root part. And they want us to simplify that. Okay, and the problem is x raised to the 1/6 power. Remember that the x and the 1 always go together, and the 6 is going to be what makes your root out here. So this is the 6th root of x to the first. Well, they are not going to put the 1 there because that's just understood. So you've just got the 6th root of x is going to be your answer on that problem. Okay, so they're wanting us to rewrite without rational expressions. So they want us to move it to having our radical sign as part of our answer. Okay, question number 2. Oh, so that's number 1. Question number 2 says to multiply and simplify by factoring. So we're going to multiply and simplify by factoring. And the problem that they've got is 2b to the third, the square root of 2b to the third, times the square root of 10c to the fourth. Okay, so what you're going to want to do is see if there's anything that you're able to pull out front of these factors, anything that has a pair. So 2 is prime, so I wouldn't be able to do anything with that, but b to the third is really b times b times b. Okay, 10 is really 2 times 5. That's the prime factorization of 10, and then this is c times c times c times c. Okay, so underneath my radical, I'm still going to have, I'm going to be able to put all of this stuff together first. So all of my numbers together would be 2 times 2 times 5. Then I still have these 3 b's, and I have 4 c's. Remember that anything that has a pair gets to come out to the front. So I've got a pair of 2's. 5 does not have a pair, so it would stay underneath the radical sign. Got a pair of b's, so I get to pull one of those out. But this b doesn't have a pair to go with it, so it would stay underneath. I've got a pair of c's, so I would get to pull that c out. Now I've got another pair of c's, so I would get to pull that c out. So my final answer would be 2b c squared, because I've got 2 of them, and then the square root of 5b. Okay, so this is what I would want to put for my final answer. These 5 and this b had no square root, had no pairs, so we couldn't pull any of that stuff out. Okay, the next problem says to multiply the square root of 8 minus the square root of 2 times the square root of 8 plus the square root of 2. Now I'm going to do this the long way just so that I can show you, but I'm also going to show you on the graphing calculator in just a minute. But you would use FOIL. So first outer, inner, last. So the first would be the square root of 8 times the square root of 8. the inner, almost went to the last next, the inner would be negative square root of 2 times the square root of 8. So first, and then I've already taken care of inner. Outer would be the square root of 8 times the square root of 2. And then the last would be negative square root of 2 times the square root of 2. So this is going to give you the square root of 8 times 8, which we know if we have a pair, we can pull that out. That's just 8. This is going to give me the square root of 16. And the square root of 16 is 4. It comes out even. This is also the square root of 16. So it's 4. And then I've got minus the square root of 2 times 2. There's a pair of something, so I get to pull those out. And so 8 minus 4 plus 4 minus 2 is going to give us 6. Okay. You can also go to the graphing calculator and just type this in the graphing calculator. I'm going to show you that real quick. So if I just type in second square root, eight, and I need to put my parentheses like they had, so hold on. Minus, and this is just the problem that they gave me, the square root of 2, close my parentheses, and if you'll notice, I needed to I need to get outside the radical sign before I close them, times the square root of 8 plus the square root of 2, and I hit enter. It also tells me the correct answer is 6. So that's another good way to make sure you're checking your work on this one. And while we're on the calculator problems, the next problem on this page is take the cube root of 27. And to do that on the calculator, you hit math. Okay, and you can see number 4 says the cube root of 27. And the answer is 3. So there's another calculator problem that you can do. So that next problem, this was number 3, this is number 4. The cube root of 27 ended up being 3. And the reason that it did is because we were looking for 3 numbers that were all the same. 3 times 3 is 9, times 3 is 27. Since there's a 3 out here, we want a group of 3 that's going to equal that. That's why the right answer is 3. Okay. Okay, let me stop this right here. I'm going to check on my student real quick. All right, how's it going? Is saving time? Well, and what you might have been doing is not getting that.
It says. No, it says.
And you notice when you try to go to the next problem on the first time you did it, it's like this result may not be saved if you don't check your answer. I wonder if you would do that.
Not sure.
You're not checking your answers. And you go to the next. Now you can still work that part over if you want to. They can all be right at the time. For the test, it's going to be right at the 80. But you got to click on it, you got to hit improve my score, and you got to check on it.
So how many different?
You don't have to do the videos in the PowerPoint, so those don't count for our information grades. So you just want to go through them and make sure you've got next
Every other one, basically.
Yeah. And your test and quizzes.
Yeah, I've done.
So you just want to follow correct. that's okay. Probably see if it is, and you got something right, it automatically pops up.
Okay,
That's- And so you go back and do this.
okay,
So you can do that on the test.
all
You
right,
don't need to practice.
Yeah. All right.
So I hope that helps.
Yeah.
I think, yeah, you just need to practice.
yeah, I'm just gonna go to the library.
Yeah, you can catch up, you just gotta get on.
I hope you have a great day. I'm glad we figured that out.
Thank you.
Okay, the next problem, number 5, and I will post this study guide after I get done with this, is to simplify by factoring. Okay, and the problem is the square root of 90. So we need to find the prime factors of 90. I will start with 2. 2 will go into 90 45 times. Okay, 2 won't go. Then I move up to the next prime factor, which would be 3. And 3 will go into 45 15 times. 3 will go into 15 5 times. And then we're done because 5 is prime. So the square root of 90 is the square root of 2 times 3 times 3 times 5. We're looking, because this is understood that it's a 2 out here when there's nothing written here, we're looking for roots of 2. So I've got a 3 that I can pull out, and underneath I've got 2 times 5. So that's 3 square root of 10. And that is going to be my final answer on that problem. You pull out the things that have a pair and you leave the other stuff there. So that was number 5. Okay, let's look at 6. Number 6 says to solve this problem. Well, I can't solve it if both of these things stay underneath the square root sign because I can't get to I can't get to the square root. So what I'm going to need to do is undo these square roots. And you can undo a square root by squaring them. So to undo a square root, you have to square them. And you can square both sides of the equal sign. That's just going to that's going to do exactly what we just said. It's going to undo the square root. And we're going to end up with 7y plus y is equal to 6y plus 9. Now we can't have we can't have y's on both sides and be able to solve it. So I'm going to have to move one of my y's. I could have moved the 7, but it would have made it be negative over here, and I just don't like that. But if you want to do that, that's fine. You have 1y plus 7. This is going to cancel out and turn into 9. And then I'm going to need to subtract 7 from both sides. So 1y is equal to 2. And then that's my answer. Y is equal to 2. I could plug that back in there if I wanted to see if it was correct. I could plug 2 in here for y and 2 in here for y and make sure both sides were equal to each other. Okay, number 7. It wants me to rewrite 64 to the negative 1/2 with a positive exponent and then simplify. Okay, I'm going to show you how to do this on the graphing calculator, and I'm going to show you how to do it by hand. Here's what I know about a negative exponent. It means it has to move. So if it's negative and it's on the top of a fraction right now because I don't have a bottom of a fraction, I've got to take that and I've got to move it to become positive. And this would be written like this because the 1 would stay with the 64 and the 2 would come outside. And I would need to have a 1 on the top to make sure that I'm replacing I have something up there to hold that spot. The reason it's not negative anymore is because I did basically what the rule says, which is to move it to the bottom. Well, we know what the square root of 64 is. It is 8 because 8 times 8 is 64. So it's just 1/8. Now, could we get the same answer in the calculator if we did it that way? So let's look at the calculator real quick and just type it in. So the problem was 64 raised to a fraction, so to the negative 1/2. So 0.125, well, we want a fraction and not a decimal, so we would hit math, enter, 1/8, which is exactly what we got. So there's one you could absolutely do on the calculator and get the right answer. So 1/8 for that one. Okay, number 8. There are 25 problems on this test. Okay, number 8. Number 8 says 81 3/4. And honestly, this is one that you could work on the calculator as well. But we know that the 81 and the 3 stay together and they would go underneath the square root. And the 4 would tell me to take the 4th root of that. Well, first off, what this means, I mean, if we break this down, we've got 81 times 81 times 81, okay? And here's what I know about 81. 81, 3 will go into 81 27 times, 2 won't go. I had to start with the next prime number. 3 will go 9 times, 3 will go into 9 3 times. So that means that every time I have 81, I've got 3 times 3 times 3. Okay, every time I have 81, I have 3 times 3 times 3 times 3. So what that means is I've got 1, 2, 3. And the reason I'm looking for groups of 4 is because this is a 4 on the outside. So the answer to this should be 3. Okay, but you absolutely could type 81 to the 3/4 in your calculator. And I would encourage you, especially to make sure you're getting the right answer. You may do these by hand, but you want to make sure that you're getting the right answer. So I did 81 rooftop, this rooftop button right here. And then I want to do a fraction. It said raise it to the 3/4 power. And it's telling me it is 27, which is not what I got. So now I need to go back and look at what kind of crazy math I just did because it should be what the calculator says. So let me go back and look real quick. So 81, and we're looking for groups of 4. Oh, sorry, I'm a dummy. We would get to pull out 1 3 for this, and we would get to pull out 1 3 for this, and we would get to pull out 1 3 for this because this has got a group of 4 of them. This has a group of 4 of them. This has a group of 4 of them. And so thank goodness I can have a little bit of grace and make mistakes sometimes. But we need to do 3 times 3 times 3, which is 27. Okay, which is good to have that calculated because I was able to catch my mistake on that one. Okay. Now, let's look at 9. 9 says to rewrite with a rational exponent. Okay. And the problem is the 5th root of 19. Well, here's what I know about 19. 19 is prime, so I can't do that factor tree and do anything with that. So right now, 19 is raised to the 1st power. And to rewrite it, you would write 19 You put the 1 on the top. This kind of stays together, 19 over 1, and then you divide it by whatever is on the outside. 19 to the 1/5 is going to be your answer to that. Number 10 wants us to simplify by factoring. And we've got the square root of 500 times x to the 4th. Well, we know that 500 is not prime. 2 will go into 500 250 times. 2 will go into 250 125 times. I like to go to 3 if I can, but I don't think 3 is going to work. 5 will go into, would be the next prime number after 3, would go 25 times. 5 will go into 25 5 times. Okay, so now we know that 500 is 2 times 2 times 5 times 5 times 5, and x to the 4th, we would have 4 x's. So there's no number up here. And when there's no number, we know it's a 2. So we're looking for groups of 2 that we can pull out front. And then we've got the radical sign. So this had nothing with it. So it would go underneath the radical sign. We could pull out a 2. We could pull out a 5. We could pull out an x. We could pull out an x. So 2 times 5 times x is going to be 10. X times x would be x squared, square root of 5. Okay. Number 11. We've got the cube root of negative 8 x to the 3rd. Okay. You can use some of the calculator to cheat on this. We could probably figure out what the cube root of negative 8 is. If we type that in the calculator, it would tell us it's negative 2. But I also know that negative 8 is negative 2 times negative 2 times negative 2. And a lot of students get confused right here because they're like, well, you said you can't take the square root of a negative number. Well, you can't. It's imaginary. When you do that, we're not able to do it in this chapter. But this is not the square root, it's the cube root. And it is possible for a negative 2 times negative 2 times negative 2 to be negative 8. So we're looking for groups of 3. We do have a group of 3 2's, negative 2's that we would pull out. And we have a group of 3 x's that we would pull out. So this would be my final answer, negative 2x. Okay, number 12. Simplify by factoring the square root of 20a squared b. Okay, so we would want to look at the prime factors of 20. 2 goes into 20 10 times, 2 goes into 10 5 times. And so we've got 2 times 2 times 5 times a times a times b. There's nothing up here, so we know it's an understood 2. We're looking for groups of 2. Can pull out a 2. Got a group of a's, I can pull those out. But this stuff that's left is going to have to go underneath the square root sign because it doesn't have any partners with it. So 2a times the square root of 5b. Okay, so let's look at 13. It says to find what negative square root of 49 over 25 is. Now remember, you can break these up, and we know that 7 times 7 is 49, and 5 times 5 is 25. So we're looking for pairs because this would be a 2 up here if there's nothing written here. So negative 7/5. That's going to be my final answer on that one. Number 14, find the square roots of 100. So find the square roots of 100. Now, remember that there could be two answers. The principal square is going to be the one that is positive. Okay, we know that square root of 100 is 10 because 10 times 10 gives us 100. So that's going to be the answer to that. The second part of this says the negative square root of 100 Okay, well, the answer is going to be negative 10. And it is because we could also say negative 10 times negative 10 is 100 because negative times a negative is also positive. So it could be either one of these. And this is how they would want you to write your answer. Okay. Number 15 says to rationalize the denominator, which is something we covered in the very last section. Rationalize the denominator. Okay, so we've got the square root of 10 over the square root of 7. We know that we can write this, we can split them apart like this. Now, it is not reduced when you have a radical or a square root on the bottom. And the way that you get rid of it is you multiply it by 1. And the square root of 7 over the square root of 7 is 1. Just like if I wanted to do 1/2 times 2 over 2, that's multiplying by 1 because it's the same thing on the top and the bottom, and it wouldn't change anything. That would give me 2/4. Well, guess what? 2/4 is 1/2, which is what I started with. But the whole goal here is to always multiply by whatever is on the bottom. And that bottom needs to be the same on the top and the bottom here so that those will cancel out and you're 1. Because what ends up happening is we get 10 times 7 on the top, and on the bottom we get 7 times 7. Well, we have a pair. We get to pull that pair out, and that makes it where we don't have a fraction that's not reduced because we don't have a square root on the bottom. And square roots or rationals or radical signs are not allowed to be on the bottom. So we have rationalized the denominator. Simplify that fraction pretty much. Okay, we'd also want to see if 70 would reduce. I'm going to look at that just real quick. 2 will go into 70 35 times. 5 will go into 35 7 times. So 2 times 5 times 7, they're not going to have any pairs to pull out because they're all different. So this would be our final answer on that. Number 16 says to multiply the square root of 2 plus 3 square root of 5 times the square root of 2 minus 3 square root of 5. Okay, I'm going to do this and then I'm going to show you in the calculator what it would look like. But we've got the square root of 2 times the square root of 2. That's the first. Got your outers, which is going to be a negative 3 times the square root of 5 times the square root of 2. The inner, which is going to be a positive 3 square root of 5 times the square root of 2. And then we've got our last terms, which is it's positive times a negative. So negative 3 times 3 and square root of 5 times the square root of 5. Okay, well, we know that if we've got a pair of things, this gets pulled out. On this one, we've got negative 3, and then we've got 5 times 2. So that's just going to be negative 3 square root of 10. This is positive 3, 5 times 2. So positive 3 square root of 10. This last one, negative 9, and then we would have 5 times 5 underneath the radical. So we could pull one of those out. So that would be end up being negative 9 times 5. So these go away because they're the same. One of them's negative and one of them's positive. So we really have 2 minus 9 times 5, which is 45, which is going to get us negative 43. Okay, this is one of those problems I definitely would check on my graphing calculator. So I'm going to go there real quick and just show you what I would do if I was working this problem on the graphing calculator. So I have parentheses, second square root. I'm just typing in the exact same problem we had. Plus, this just helps me make sure that I've got the right answer. If there's a discrepancy somewhere, I can go back and maybe figure out, did I type it in wrong or did I solve it the other way wrong on paper? And it takes maybe a little bit extra minute, but it's good to definitely be able to check your work this way. Okay, now it looks exactly like it does on the paper. So I'm gonna hit enter and it tells you the answer is -43, which is what we got. So we did good. Okay, I just want to point that out that that's another thing that you have going for you. Be able to check your work on several of these problems that way. Okay, number 17. And once again, we have 25 problems on this. So we are getting there. Negative square root of 49. Okay, here's what we said. We can't take the square root of a negative number. Now, you're fixing to find out in chapter 7 that that's a little bit of a not true statement. It just, they are imaginary numbers when we take the square root. I'm not going to be able to do this one because it's a non-real number. If you were to type it in your calculator, you could, it's going to tell you something like that. In fact, let me show you what, and so you should know. I'm going to go to my graphing calculator real quick, just to show you what, it's going to say something like non-real. So second square root, -49, enter. See, in real mode, all calculations must result in a real number. It's a non-real answer. And that's true. It is a non-real answer. And on your test, you're going to put, I'm going to go show you where that is. We're on number 17. So you're going to want to pick the square root is not a real number on this one. So it doesn't have an answer. It's just non-real. Well, it's an imaginary number. And so in this chapter, you don't have to write the answer. So number 18, solve the square root of x plus 9 is equal to -3. Well, the first thing I know is I can't solve anything if it has a square root. I've got to get to that x. So to get rid of a square root, you have to undo a square root, you have to square it. And whatever you do to one side, you have to square the other side. Make sure you put the whole thing in parentheses, but you want to square the whole thing, not just the 3. You want the negative to go with it. -3 times -3 is 9. When I squared the square root, it undid that. So I am going to subtract 9 from both sides. So x is equal to 0. Okay, so this problem is kind of weird because what we know is we're not supposed to be able to take the square root of something and get a negative answer. If we did -3 times -3, we get 9. If we plug a 9 in, 9 minus 9, or 9 plus 9 is going to be 18. If we plug a 0 in, 0 plus 9 is 9. And we take the square root of 9, it is possible to get -3 because -3 times -3 works, okay? But when that comes up as this, what you want to do on number 18 is you want to put, there is no solution. Okay. Number 19, the square root of 18 over the square root of 2. 2 will go into 18 9 times. 3 will go into 9 3 times. So we know that 18 is 2 times 3 times 3. The square root of 2, I can't really do anything with that. This has a pair. No, we're looking at, these are both squares because there's nothing out there. So that means I can pull the 3 out front and the square root of 2 would go stay underneath. And on the bottom, I would have the square root of 2. Well, these are exactly the same, so they're going to cancel out and I'm going to get 3. Sometimes it's possible to check these on the calculator. This is one of those times where it would actually come out the way it's supposed to if I type that in. So if I go to and I type in alpha y equals a fraction, I do second square root, and I hit 18. That's my arrow. Second square root, 2, my arrow, enter, 3, which is what we got. So don't be scared to, sometimes they're not going to come out perfect like that, but don't be scared to use your calculator to see if you can check your work. It'll help you get the right answers more often than not. So let's look at 20. 20 says that we are to rationalize the denominator on this one. So we've got 14, the square root of 3, 3 times the square root of 7. We know that the thing that we're trying to get rid of is in the denominator, and it is the square root of 7. I'm not allowed to have a square root or a radical sign in the denominator. If that's there, that is what you have to multiply by on the top and the bottom. It's the same thing as multiplying by 1. So I would end up with 14 times the square root of 3 times the square root of 7. On the bottom, I've got 3 times the square root of 7 times the square root of 7. Well, this is going to be 14 times, I can put that together, 3 times the square root of 7, and 3 square root of 7 times square root of 7. Well, we've got a pair, and since this is a 2 out here, I would get to pull that one of these 7s out. And on the top, I've got 14 times 3 square root of 7. Okay, well, that's going to be 14, the square root of 21, and then 3 times 7 is 21. Now, the last thing you want to do is make sure you can't simplify this anymore. And I'm noticing square root of 21 is 3 times 7, and 3 times 7 are both prime, so I'm not going to be able to do anything with that. However, this 14 and this 21, this is a fraction. And you can reduce this fraction because 7 goes into 14 2 times and 7 goes into 21 3 times. You could also go to your calculator and type in 14 over 21 and reduce the fraction that way by hitting their math, enter. But then I would write my final answer because 14 over 21 is 2/3. Okay. So we have 5 more problems. Okay. One. Says subtract 8 times the square root of 125 minus 5 times the square root of 5. Well, the first thing I'm going to have to do is I'm going to have to do the factor tree because these are different. And if they're different, then I can't subtract them the way they are right now. It's kind of like they don't have a common denominator. I know that 5 will go into 125 5 times. 5 will go into 25 5 times, and then we're done. So this is really 8 times the square root of 5 times 5 times 5 minus 5 square root of 5. Okay, we can pull out a 5 because there's a pair of them. So the 8's already out there. The 5 gets to come join it. But this 5 right here does not have a pair, so it would stay underneath. This is already prime, so there's not anything I can do with that. 8 times 5 is 40. So I've got 40 square root of 5s minus 5 square root of 5. So that's going to be 35 square root of 5s. Because these are the same, now we can subtract them. Okay, 22. This one's easier because it says for us to add 2 square root of 10 plus 7 square root of 10. Okay, well, these are already the same. So we can go ahead and say, well, 2 and 7 is 9 square root of 10. 10 is prime, it's not going to reduce. There's nothing else I can do with that. Okay, 23 says to multiply the square root of 2 times 4 minus 7 times the square root of 2. So we know we have to use the distributive property. That's going to be the square root of 2 times the square root of 4. I apologize, that's a regular 4, not a square root of 4. So we have to take whatever's on the outside, which is our square root of 2, and multiply it by both things on the inside. Then we need to do square root of 2 times this whole thing. Well, that's negative 7 times the square root of 2 times the square root of 2. Okay, so this whole thing would combine and give me 4 square root of 2. This whole thing is the 2's underneath. Well, those are a pair of 2s, so that should be able to be pulled out and be able to go with 7. So we've got 4 square root of 2 minus 14. Okay, and you can leave your answer like that. Okay, 2 more problems. On 24, problem says that we are to add or subtract. Basically, we're just trying to simplify this expression, 6 square root of 128 minus the square root of 50 plus 5 square root of 8. Okay, well, we're going to have to simplify or find the prime factors of every one of those things. Hey, Jerry, you want it? It's fine. And so we want to start out with 128. 2 will go into 128 64 times. 2 will go into 64 32 times. 2 will go into 32 16 times. And we could keep going with this because this is a lot of 2's. So this thing is really 2 listed, what, 7 times? Okay, minus. Then we're going to look at our 50. Well, 50, 2 will go into 50 25 times. 5 will go into 25 5 times. And then that's it because 5 is prime. So minus 2 times 5 times 5. And then we need to deal with our 8. We've already got a 5 out here. 8 is 2 will go into 8 4 times. 2 will go into 4 2 times. So 2 times 2 times 2. So we've got 6 square root. Now hold on a minute. Let me erase that real quick because we need to think about what's going to happen here. Anything that has a pair, we're going to be able to bring out with the 6. So we've got one pair of 2's that could come out there, another pair, and one final pair. And so I think I listed one too many. There's supposed to be 7 and I have listed 8. So let me erase one of those. If I erase that one, then I would have one for this one, one for this one, one for this one, and we had an extra that would stay underneath. Okay, minus, we can pull out a 5 because there's a pair of 5's, square root of 2. We've got another pair of 2's, but we've already got this 5 out here. So then we got a 2 left. So now, let's kind of draw a line so we can keep it straight. 6 times 2 is 12, times 2 is 24, times 2 is 48. So we have 48 square root of 2's minus 5 square root of 2's plus 10 square root of 2's. A 48, since they're all the same now, all square root of 2's, we can combine them. And 48 take away 5 is going to be 43, plus 10 is going to be 53 square root of 2's, and that's going to be the final answer on that. Okay, last problem, 25. We want to solve the cube root of 5x plus 7 equals 8. Well, we need to get everything away from that x. I'm going to start by moving this 7 to the other side of my equal sign. 8 minus 7 is 1. And then I've got the cube root of 5x plus 7. Well, to get rid of a square root, we squared it. So to get rid of a cube root, you're going to need to cube both sides. Well, 1 times 1 times 1 is still just 1. But on this side, that's going to get us 5x plus 7 because we undid the cube root. So we're going to subtract 7. 1 minus 7 is negative 6. Divide by 5. So negative 6/5. And it is fine to leave your answer that way. Okay, so that was the end of chapter 6 review.